I'm Connor Higgins.
I'm Austin Johnston.
I'm Quinn Albertson, and our other team members are Hassan Dahani, Omar Youssef, and Matthew Connolly, and our project is the fluid dynamics of a hydrofoil surfboard. Alright, so here's our hypothesis. Lift acts as the applied force which causes the surfboard to elevate above the surface of the water, thus minimizing drag from the surface of the water.
Swell is a transfer of energy through the water molecules. The water itself hardly moves, it simply oscillates. When the height of the swell reaches double the depth, the wave stability is undermined and the water is thrown forward, forming a breaking wave. A surfer cannot overcome the surface drag of the wave until it begins to break. The hydrofoil effectively minimizes this drag by providing lift to the surfboard, elevating it above the surface of the water. This lift acts perpendicular to the flow as described by the equation for lift, which was covered last week in class. By maximizing the lift, the drag is minimized, allowing the surfer to surf larger waves in deeper water and at higher velocities.
To show what the actual hydrofoil looks like under the water, we have this picture, and from what you can see, according to this schematic, is as the velocity increases across the hydrofoil, it increases the lift, which is perpendicular to the foil, causing the surfer to come farther up out of the water.
The foil is shaped to move smoothly through the water, causing the flow to be deflected downward, which according to Newton's third law of motion exerts an upward force on the foil. This turning of the water causes higher pressure on the bottom and reduced pressure on the top of the foil. The pressure difference is accompanied by the velocity difference via Bernoulli's principle that results a higher average velocity on the side than the other. As you can see here, the initial momentum and the final momentum results into a downward force. According to Newton's third law, there must be an equal and opposite momentum exchange, and that's why it exerts an upward force. That force is causing the lift on the hydrofoil.
Now, for our conclusion, we came up with the hydrofoil makes use of the conservation of momentum in the famous Bernoulli's equation. The upward pressure caused by a positive angle of attack increases lift. Now, by maximizing the lift, the drag is minimized, allowing the surfer to surf larger waves in deeper water and at higher velocities.